three-dimensional finite element analysis output is shown here, showing the calculated stresses. And because they're such a good contractor, I wanted to show their detailed shop drawings too. First showing a plan view at the top, showing a bundle number 18. So two number 18s had to be swallowed by a specially designed U-bolt, which is connected to the lift collar to secure everything properly. So despite all their calculations and thoughtful drawings, they did the right thing also by performing a full-scale load test. And shown here is that lift collar being attached to a nearby dock they have. And all that sound engineering resulted in a great successful operation as shown here, 60-foot shaft being ready to be lowered into the ground. And also wanted to further demonstrate this cap. I'm trying to find my cursor. Here we go. So the lift frame, I have a little animation here to just really drive home the point of how they constructed this and fabricated it. So you start with two halves of the structural steel collar, spliced at the joints with conventional bolts and splice plates on the top and bottom flanges. Bolted up nice. Next, you have the custom U-bolts, which were also tested in their shop, bolted to the lift collar with the rigging plates and shackles ready to go. So speaking of connections, what's really common is to use Crosby clips, or technically wire rope clips, to connect rebar. Many ways. One is, the longitudinal bars to the pickup bars. Other times you'll be using Crosby clips or similar to connect to support frames, lifting collars, etc. The bottom line is, while these are a great mechanism to use and we highly recommend them, they must also be tested. And the reason being is the catalog is talking about wire rope to wire rope connections of equal diameter. And what we know is that people are going to want to use different size bars. We're going to need to connect different size bars together, or a bar to a plate, or a bar to a channel. All these different combinations doesn't cost that much, need to be tested in the presence of an engineer or out in an independent lab. And once those results are obtained, we recommend using a factor safety of 2. So here's an example of a lift frame plus a temporary support plus some of these U-bolts that was performed on a project in Manhattan. Here showing a simple lifting channel, right? Some of the best details are the simplest. It's channel connected to the bars with the Crosby clips, and here's a temporary support, similar type construction. The rebar cage being suspended on the guide walls for a slurry wall with the channels and the Crosby clips. And here's a photo of that exact operation in progress. Again, a lot going on here. What I just wanted to point out is on top is some lifting frames that are connected to pickup bars, which are actually extended above the hole because this is a top-down construction job like most slurry wall jobs. And this cage had to be lowered about another 10 feet. Temporarily, though, it's supported on these supports on the guide wall, which again are just simple channels with the Crosby clips holding it in place, getting ready to be concreted. Quick word on embeds and instrumentation. We know they're necessary. We know that also it seems to get fairly congested with a lot of unique shapes required, and in particular, we get a lot of O-cell needed, Osterberg load cells, that is, at the bottom of drilled shafts. We know they're important. We know they need to verify the design capacity of the drilled shaft. Also, we know that it's difficult to get concrete around them, just like any embed or block out. So, the O-cell shown there on the bottom. A little detail we found that works well is to create a funnel shape with the rebar to more or less force that Tremie hose to be centered right over the hole in the O-cell. to assure that the concrete gets underneath and all around and above that OSO, completely encapsulating it. So this is one trick we'd like to see used more often. And finally, speaking about embeds, here's probably the largest embed we ever dealt with. It was so big, in fact, that eliminated the need for the pickup bars, and the bars were actually connected to the embed. Might be a nice picture. It was certainly not an easy job, but it is done at this point. So let's move on then to the summary of everything we've learned today for the best practices, starting for the number one person, the permanent design engineer. So what we'd like to say is that whenever possible, you should consider increasing the stiffness of the rebar cage. How do you do that? Increasing the quantity and size of longitudinal bars. As Ben mentioned in his graphs, they provide additional strength. Of course, specifying internal bracing, it should be a must. Minimum 4 number 8s, 10 foot on center is a good start. We know that 8 in the square configuration is even better, or structural steel even better. Allow the bracing to remain in place, and if you're concerned about seismic design, keeping the flexibility in the system, well, try to account for it. There's ways to do so. Vitani's document is available. Allowing use of weldable rebar would be great, and we know that many states and authorities don't allow it. It's starting to become more and more common. It's not a big cost impact. It would really, really stiffen up that cage nice. So designing with constructability in mind, of course, is always a goal. Should anticipate that splicing will be required. Try to avoid irregular rebar density. Like I said, like it's typically heavy at the top. If we ran some of the bars a little bit longer, just not go from ridiculously heavy to ridiculously light cages. A few extra bars is going to aid in the lifting and handling. On the same project, there's no reason to have 6 different or 8 different size shafts. Each one of them requires special tooling and equipment, as well as rigging, crane, lifting and handling practices. And I don't know if you hear my radiator there in the background, hopefully I'll talk over that. So we want to avoid multiple diameters. You might think you're saving money, and in reality, it's probably a wash if you just have a couple sizes. And consider the difficulty associated with your embeds, blockouts, and instrumentation, especially if they're in the same element. If we could spread them out over a couple elements, it'd be much preferred. So now let's talk about number 2 guy, the contractor.